Okay, so I skipped over number 2. Maybe at a later date I'll go back and do it. Number 2 is pretty similar to number 1. Let's do number 3. It's a little bit different, a little bit unique. Here we go. Inez uses hairspray on her hair each morning before going to school. The spray spreads out before reaching her hair, partly because of the electrostatic charge on the hairspray droplets. It's a mouthful. If 2 drops of hairspray repel each other with a force of 9.0 times 10 to the negative 9 newtons at a distance of 0.07 centimeters, what is the charge on each of the equally charged drops of hairspray? Okay, so here we go. Alright, so let's start by writing what we know. So we know that we have this. We also know that it's in newtons. That's our force, which means that's the F of our formula, right? So our electrostatic force equals 9.0 times 10 to the negative 9 newtons. Okay? Next, we know that we have distance. Distance equals 0.07 centimeters. And what do we not have? Charge 1. Charge 2, right? Also note that it says they are equally charged, so we know that this and this are the same, right? Alright, so let's write our formula. Force of electrostatic force equals I almost said gravitational constant. Electrostatic constant, charge 1, charge 2 over distance squared. Next, we are going to plug it in. So we got our force, which is 9.0 times 10 to the minus 9. That's our force, equals electrostatic constant, 8.99 times 10 to the 9th power, times charge of 1 times charge of 2, because we don't know those charges, right? Over distance, which is 0.07 centimeters squared. Okay? Alright, so let's see what we get. First thing we can do is we can go ahead and square the bottom, or not, whatever we want to do. Let's bring the bottom over. Okay, so I want to get rid of this denominator, so I'm going to multiply the whole right side times 0.07 squared. That cancels this out. Boom, boom. Which means this is 0.07 squared. So we're multiplying this, that way it's gone. Okay, then we will have, let's see, 4.41 times 10 to the minus 11 equals 8.99 times 10 to the 9th times charge of 1 times charge of 2. We know they're the same charge, right? So I'm going to put a line over here so we know they're separate, right? Next, I need to get rid of this. These are Q's, by the way. There we go, Q1, Q2. So I'm going to divide this side by 8.99 times 10 to the 9th. That cancels them. Divide the left side by 8.99 times 10 to the 9th. And that should give me, I'm going to come over here to the left. That should give me about 4.91 times 10 to the minus 21. And this is what I'm going to do for here, okay? So instead of writing Q1 times Q2, they're the same. So I'm going to write Q squared. Okay? So instead of writing Q1 and Q2, because they are the same charge, I'm going to write Q squared. Okay? And that's going to make it easier for me to finish it. So we want to get rid of this square. What do? We square root this side, which means we square root this side. So we're going to have Q equals, in other words, the charge of 1 and 2 should be about 7.0 times 10 to the minus 11. And there you go. And you know this is Q1 and Q2 because, again, they're the same charge. So we have solved it. There's different ways of going about it. So if you did something different at the beginning, instead of getting rid of the denominator, you wanted to get rid of the number in the numerator, whatever, as long as you came up with the same answer in the end. So that's how to do number 3. You guys got any questions? Let me know.